two sessions, okay, morning and afternoon. But I'm just going to combine both. So for today, we will see experiment 2 and 3 first. Okay, we're going to skip experiment number 1 because I personally cannot go into our campus because it is already a PKPD area and I'm living outside of Negeri Sembilan, so I cannot go to the campus. So for today, we will see experiment number 2, which is the synthesis of 7-hydroxymethylcoumarin. So this is an example of heterocyclic compound, okay, and also it is an aromatic. The starting material that you are going to use is resorcinol and also ethyl acetoacetate. Later I will show you the videos for the reaction, both reaction, experiment number 2 and also experiment 3, which is the synthesis of benzotriazole. Okay, so on the background a little bit, the principle. So basically, the reaction involves uh, resorcinol and also ethyl acetoacetate, and this um, reaction is also known as Perkin synthesis. So this coumarin, methylcoumarin, okay, is usually prepared by heating salicylaldehyde with acetic anhydride and also uh, sodium acetate by giving sorry, what you call that, cyclization to give coumarin. So in which that originally you already have one benzene ring, you are going to add another cyclic, okay, through one of the OH group over there. So the ethyl acetate will form a cyclic ring with the benzene ring itself. So the name of the reaction is known as Perkin synthesis. Okay, so the one below we are using resorcinol, which contain other substituents compared to the salicylaldehyde. Salicylaldehyde is an aldehyde with C double bond OH. Okay, so coumarin having substituents in the benzene ring um, can also be similarly prepared. Okay, so using different starting material, as long as the main structural is almost the same, so we can still conduct this Perkin synthesis. So for preparation of 4 substituted coumarins, okay, a phenol may be condensed with ethyl acetoacetate under the acidic condition of sulfuric acid. You may add sulfuric acid, and also the reaction must be done at a very low temperature. So in this particular reaction, the resorcinol readily undergoes this condensation with ethyl acetoacetate, okay, in the presence of concentrated sulfuric acid and the reaction also must be continuously stirred to form the said product. Note that all coumarins, like all 2-pyrones, are systemically lactones. So in the procedure, basically the sulfuric acid is going to be added first or prepared first into a conical flask or beaker, okay, because the all of the reagents and starting material must always be in a cold condition. You see the temperature over here, it is between 0 to 10 degrees Celsius. So the first step state that you are only going to require 7.5 ml of concentrated sulfuric acid. So this is quite a lot, and If the reactions are to be done in our lab, definitely I'm going to ask you all to do it in the fume hood, okay, because 7.5 ml is quite a lot. Okay, and it is going to be stirred magnetically using a magnetic stirrer in a conical flask or an aluminum flask with external ice water cooling. So that means you're gonna have to create an ice bath first. Okay, what is an ice bath? Like the one below. So this is an example of ice bath, and you're gonna have this mechanical stirrer or magnetic stirrer, so that the sulfuric acid will be always you're gonna get cool evenly. Okay, so you don't need to use glass rod to stir the solution. So the temperature must be kept at around 5 degrees Celsius. So you're gonna check using a thermometer. Then in a separate flask, okay, you're gonna add 1.85 gram of this powdered resorcinol. So it is in a solid form to about 2.25 gram of ethyl acetoacetate. So it is given in gram, but you have to convert that into volume because ethyl acetoacetate is in liquid solution. So you can calculate that by using the specific gravity or density of ethyl acetate to find out the volume. Okay. So add solution 2 slowly to the sulfuric acid, which is the one you have prepared in number 1, so that the temperature of the mixture does not rise above 10 degrees Celsius. Then it is very important to keep the temperature low, okay, because this is an example of exothermic reaction in which that heat will be released. So the reaction prefers, if you want to form any product, the whole reaction temperature must be kept very low. And then the stirring shall be continued for about 30 minutes. Only after that, you can start to stop the stirring process and then pour the whole thing into a crushed ice, okay, about 50 to 100 gram, meaning that a very cold solution. Then the product will start to separate. Then only you can filter the whole thing. For purification, okay, the one step number 5, that is purify or recrystallization process. The product that you obtain in number 4, once you filtered, will be dissolved in cool 10% aqueous sodium hydroxide, NaOH. So that means you have to first cool NaOH in an ice bath. Okay, the volume that you need is just enough so that you can dissolve the whole thing. So I will not put a specific volume like 5 ml, 10 ml, because the amount of product formed in number 4 will be different for each one of you. If you are doing it in the lab, some of you may get a lot, some of you may get a little bit, because each of you are doing things differently probably. Okay, there might be some little error, too much acid added or things like that. Okay, then it will be reprecipitate by the addition of dilute HCl. Okay, the volume same as the amount of the sodium hydroxide added. After that, uh, it can be recrystallized from ethanol. Okay, and then only you can filter it again, and you can dry the product form, so the uh, weight can be measured. Okay, we'll see this example first. Let me share. Okay, I haven't post. I'm gonna post the material for today. Okay. So this is a video showing the synthesis of formita Can you hear the sound? No.
Can, sir, can.
Okay.
Place 40 ml of concentrated sulfuric acid in a 250 ml beaker and cool by keeping the beaker in an ice bath. Make a solution of 5 gram of resveratrol in 6.8 ml ethyl acetate. Add clockwise solution of ethyl acetate and resveratrol in concentrated H2SO4 continuous stirring. Pour the solution in a beaker containing 50 gram of ice. Add dilute hydrochloric acid for reprecipitation. Filter out the precipitate obtained by recrystallization. Recrystallize the obtained product with phenol.
Okay, so based on that video, the only thing that is different is the amount used. Okay, the one that in the manual, in our lab manual, in KPGC lab manual, has slightly different amount. But overall, almost all of the method is the same. So it's just different apparatus. Like in the video, they use the three leg stand as a holder for the funnel. Okay, but if you already have retort stand or something like that, you can also use. But basically, uh, for that experiment, it has been shortened into a 4-minute video, but actually in the lab, it will take about maybe at least 1.5 hours for you all to complete. Okay, some even for your seniors it will take two, maybe even until the end of the lab sessions. They just obtain the final product. Okay, then we'll see the other experiment. Wait, sorry. Okay, for the calculation over here, um, you don't have the raw data for the actual experiment. So what you can do is, one, you can try to find uh, online literature if they have, but by next week, if you are finding it hard to get any of this, I'm going to give the raw data from your seniors lab report if I can find some of the soft copy lah. Okay, so for the raw data that is needed is just uh, this one is molecular formula, molecular weight, product. This one, the gram of resocinol. Over here, it is stated that 1.85 gram of resocinol, but in reality, when you weigh the resocinol using the actual analytical balance, you may get 1.85 uh, 99 or 1.8501. So there could be different value. So it must be written over here. Okay, then only you can calculate the theoretical value of the product, because you are going to calculate the number of mole using this reaction formula. So 1 mole of resocinol will produce 1 mole of the coumarin product. Okay, then the other raw data needed is just the practical yield. Okay, how much of the product that is formed. So probably I'm going to give you these two value in the Google Classroom as well. Later I will edit some info on there, so you will be able to do the calculation for this part. Okay, to calculate the theoretical yield. Then for the third experiment, which is synthesis of benzotriazole, so another synthesis experiment. So in this reaction, you are going to synthesize a heterocyclic compound also, but containing 3 nitrogen in the ring. So that hence the name triazole. So if you have nitrogen, normally you add the prefix aza. So triazole. Benzo refers to the benzene ring itself. So normally the benzotriazole derivative will have chemical and biological properties that can be utilized in pharmaceutical properties or pharmaceutical application. So normally it is a synthesis of the benzotriazole involve the reaction of orthophenyldiamine. This is your starting material of orthophenyldiamine, and sodium nitrite, KNaNO2, and also acetic acid. Okay, acetic acid So this conversion proceed via the diazotization of one of the amine group. If you still remember, this is also available in the lecture notes. Okay, the diazotization of the amine group. So these so-called benzotriazole structures will be formed. So the synthesis can be improved when the reaction is done at low temperature. Also for this one, the reaction have to be kept at low temperature. So you are going to use um, ice bath as well. Okay, same like the reaction above. So an ice bath, oh tak ada gambar. Okay, the procedure involve basically in step 1, you are going to weigh the starting material of orthophenylene diamine, these structures, and add the solution of this H plus refers to the glacial acetic acid, okay, 3.81 in 10 ml of distilled water. So warm slightly the content uh, on steam bar or on hot plate just to make sure that everything is dissolved. This one, this orthophenylene diamine is already been dissolved until it becomes clear solution. Then only you can cool it down because the reaction only starts when you add the sodium nitrite. So before you add the sodium nitrite, the whole orthophenylene diamine must be cool first, okay, in an ice bath. So you are going to add 2.5 gram of 2.5 gram of the sodium nitrite in 5 ml distilled water. So after adding the above solution, the content should become warm and the temperature will reach up to 85 degrees Celsius. So this you have to check using temperature. So that's why it is important to make sure that there is enough ice in the ice bath to keep the temperature low, because if you imagine if you let the reaction happen at room temperature, it's gonna increase more than 100 degrees Celsius. So exothermic reaction, and there could be chances of probably explosion or things like that, because in exothermic energy is being released. Okay, so within 2-3 minutes and begin to cool while the contents changes from deep red to pale brown. So the temperature rises only for a while, 2 to 3 minutes, then it will start to cool back down. So continue the stirring. So you have to keep on stirring for about 15 to 20 minutes, and the temperature will become stagnant, will remain the same at about 35 to 40 degrees Celsius, and you further cool all of the mixtures in an ice bath for 30 minutes before filtering the product form. Okay, then you can recrystallize it using benzene. When the procedure asks to recrystallize using benzene, that means you are going to take back all of the solid form, dissolve it in benzene. The amount of benzene is just enough so that it can dissolve. Okay, and then cool it back again. So this is done to remove any impurities that is present. Okay, so the calculation is also the same. Okay, I'm going to give you the two raw data needed, which is the weight of the orthophenylene diamine and also the practical yield of the product form, so that you can calculate the percentage yield of the benzotriazole. So we're going to see the reaction. 1 minute. Let me share the screen. synthesis of benzotriazole. Okay, sorry the uh, video doesn't have any sound, but that is how the benzotriazole is prepared. And another thing that I want to show is I've already post the rubric for the lab report, okay, in the practical manual section over here. Cannot view. Okay, so this is you can refer um, each criteria that is needed. So above here is the mark that you're gonna get if let's say over here the introduction of background sources, you're gonna get just one mark if you copy it directly rather than put into your own words. Especially if you just straight away copy from the lab manual, then I'm just gonna give you one mark only. Okay. So if you want to get 4 marks, okay, try to get other sources available. So then only you're gonna get excellent. Okay. Same as well for your procedures, the results, okay, your discussion, conclusion, and also spelling, grammar, and sentence structures will be taken into account, and your the whole appearance and formatting of the lab report. Okay, in terms of uh, it should be all sections in order, well formatted, and very readable. Okay, for low marks, and section out of order, too much handwritten copy or sloppy formatting. This handwritten copy is doesn't mean that you cannot use handwritten. It just mean that there's too much of like jotting around at the side of the report. So it must look proper, must looks nice, okay? And sloppy formatting. So this one you can refer so that you know what to get. So try to do a good report because in your lab report, if you do very well, then I don't have any reason not to give uh, 4 marks, for example. Okay, so uh, I hope you can rewatch again the videos. Later, I'm going to update some of the raw data for the experiment, and uh, we'll see uh, whether it is uh, allowable. I'm not sure whether you guys can do the actual or physical lab or not, because according to the current situation, even the campus is also closed.